See if this works. Hey, I'm going to put the video back on here, and this is a great little video of how small an atom actually is. And you can see the measurements down there at the bottom. You can make this full screen if you want. Good morning, Miranda. Good morning, Rupiah. So there are all the elements in the compounds there. Good morning, Alexis. Those orbitals are funny shaped, aren't they? Some of the smaller orbitals, see there, you can see are spherical, but the larger ones are lobe shaped. And such a tiny, tiny little nucleus, way, way down deep inside those electron clouds. All right, so what do you think about how small atoms are and how small those subatomic particles are? Good morning, Hadaya. Good morning, Daniela. Oh, that's a problem. So what do you think about how small atoms are and how small those little subatomic particles are? And thank you very much for telling me my mic is off. I was saying hello to Giovanni, Hadaya, and Daniela, and Miranda, if I missed you. And Giovanni, I think you're on the pretest list. Let's see here. Nope, you're not. You're good. Hadia. I think I have that on my wall already. I do. Hadia. Keep me on task that I say that correctly. Good morning, Isaac. Just looking for pre-testers. Looking for Allie, Ashler, Brittany, Caitlin, Constantino, Dakota, DeAndre, Elizabeth, Amani, Joseph, Carrington, Mason, Naisa, and I think Seth already took his too. Okay, I think I'm good. Good morning, Anna B. All right, so just a reminder that you should be respectful and courteous of everybody, and you should not share your personal information. And thus far, you guys have done a great job at conducting yourselves professionally and maturely here in class. We have a new slide of student expectations for the 2019-20 school year. And we're gonna remember to park this year, participate, attend. You're doing good at attending. Check that one off. Read and respond to emails and complete all assessments and assignments. All right, and similar duties over here. I like this little park thing. It's nice and short and sweet. All right, so I already talked about this. Let me just, oh, hey, Joseph. Let me check and make sure you haven't taken the pre-test, or you can tell me for sure. And Nigel, good morning. Good morning, Cameron. Hey, Seth. Okay, this is an old list. I didn't get a new list of pre-tests this morning. Let me just make sure you're on here. Yep, Joseph, I see you. Excellent. Seth, I believe you're on here. Yep, okay. So far, so good. Oh, you took the pre-test. Thank you for getting that done. I haven't had a new list of pre-tests, so I was just looking at the old one. You're good to go, Seth. Hey, I haven't shown you our standards yet for physical science, but here we are, and we've already done some of these. This is SPS 1, and these are the state standards. And so we've already developed and used models to compare and contrast the structure of atoms, isotopes, and ions. We'll keep working on that. We've already looked at valence electrons and the types of ions. And then this week, we're going to look at the location and properties of metals today, nonmetals tomorrow, and metalloids on Wednesday and Thursday. Their phases at room temperature. And then so far we've been working on this, and we'll continue working on using the periodic table to predict the properties. We already kind of started that. All right, so I like to show you the standards. We'll probably do that like on Mondays. I think Monday would be a good standard day. All right, knowledge check. We're going to use those emojis to answer this question, and I will be quiet. Why does a stable chlorine ion have a -1 charge or -1? And good morning, Aiden. Hey, y'all remember that part about participating? This is the part where I need you to participate. And so many of you have. Alexis, both Annas, Daniela, Giovanni, Isaac, Kessler, Rukaya, and Seth. Thank you very much for chiming in. I'm still waiting, about half of us. And good morning, Isabel. Good morning, Maya. Oh, my mic is not off. Oh, not this time. Okay. We need to work on that increased participation here. Even if you get them wrong, that's good. Then I know where you start. So Nigel, Miranda, Maya, Juliet, Joseph, please give me an answer. Isabel, thanks for putting that on the note board. And then you can answer the question on the board. Hadia, Cameron, Aiden. Ah, okay. Look at those answers coming in. That's much better. We're still not at 100%, but we're going. So I really, really like, let me try the annotations. Cross your fingers. Ah, it worked. Okay. So I really, really like the fact that nobody picked the turtle, that chlorine atoms have no electrons, and also that you didn't pick the loudspeaker. So that is excellent. So I want to remind you that chlorine started with 7 valence electrons, because chlorine, right, is over here in group 17, right, has 7 valence electrons. So its best method of becoming an ion is to gain 1 electron and become -1. And remember, electrons have a negative charge. So if you have a negative charge, then you have extra electrons. So very good. Most everybody got the smiley face on that one. Yeah, Seth, I printed everything backwards so that it's forwards to you. All right, I'm going back to my slides. We have one more knowledge check because this was a weekend, and so, you know, I find that things like trickle out of your brain over the weekend. Oh, okay. Chlorine. Whenever you have a minus charge, that means you have extra negatives, so you must have gained those electrons. If you're negatively charged, you have extra electrons. If you're positively charged, then you lost electrons. And the thing I was saying about chlorine here on the periodic table is that chlorine is in group 17. Right, there it is. So it has 7 valence electrons. It wants to have 8 to be stable. So the easiest way to get to 8 from 7 is to gain 1. Cool. All right, now moving on to our other knowledge check. According to periodic law, let me clear these. Clear feedback. How must elements be arranged for properties to repeat at regular intervals? All right, guys, I need some more answers. They stopped coming in. So Cameron, Daniela, what do you think? Thank you, Daniela. Alexis, what do you think? Giovanni, Adia, Jordan. Yes, Seth, that definitely would kill the fish. All right. That's okay, I didn't notice. I don't notice misspellings in the chat unless I can't figure out what the word is. Oh, it didn't work. Okay. All right, I can never annotate the second time. We'll come back to the burger. Okay, so on the periodic table, remember here, hydrogen is number 1. I'm sorry, that's helium. Hydrogen is over here, it's number 1. Lithium is number 3, beryllium's 4, 11, 12. What are these numbers representing here that go up? They're the number of blanks that an atom has. Yeah, Rukaya, the proton number. So would anyone like to change their answer there? Ooh, I hear some changing going on. Anyone else gonna change? So it's funny that the mass doesn't actually put them in order because of those different isotopes. It's possible to have one more proton, but not necessarily have a lot more mass. So in order to get those properties to repeat, it has to be the number of protons. So the loudspeaker is the right answer. And actually, regarding this OK symbol, as you go across the periodic table, the atomic radius actually gets smaller because you're adding more electrons, which then get pulled in more by all those extra protons you have. and they actually get smaller as you go across. So that's kind of backwards, but definitely. And it looks like almost all of us have changed our answer to the loudspeaker, which tells me that you are hearing what I'm saying. So I wish I could draw on there, but that one was increasing number of protons. The protons. Okay. Ooh, let's pick up the mic. Let's have someone else get on the mic and see if you can fill in this blank. Just read the whole sentence. Oh, come on. I bet someone can volunteer. The picture might help you as well. It's kind of color coded.
All the elements in a group have the same number of electron levels?
Thank you, Rukaya, for getting on that mic. Excellent. What do you all think? Do you think she's right that all elements in the same group have the same number of electron levels? And remember, let me just point something out here. Hydrogen and helium, they had 1 electron and 2 electrons, right? And so that was the first electron level. Then lithium has 3, sodium has 4 electrons, boron has 5, 6, 7, 8. So this, all of these guys actually have 2 electron levels because they're in the same, what are these called that go across? Period. Yes. So groups have a lot of stuff in common. No, it's okay. Groups have a lot of stuff in common, but we didn't talk about this very much. So I wanted to make sure and cover that. So, okay, maybe I should have put this one first. Let's see if I can get someone to pick up the mic and read the sentence and fill in the blank. Seth, you want to get on the mic real quick? Oh, well, that's okay. Would anyone like to agree with Seth or disagree with Seth about atomic number? The elements in each group or family have the same number of atomic number in their outer level. Okay, Isaac's going with valence electrons. Okay, we got a second for the valence electrons. Seth, you're changing your mind, huh? Uh-oh. Uh-oh, Cameron, I don't like that you're confused. Okay, and Isaac was correct that elements in each group have the same number of valence electrons. So everybody here in group number 1, red on red, in group number 1, those all have 1 valence electron. Remember, valence electrons are electrons in the outermost electron level, furthest one out. And so group 2, how many valence electrons do these have? They have 2. How about group 18? How many do they have? Yeah, they have 8 because we drop all those ones. Those ones just count the 10 transition metals that are there. Oh, I told you something about today. All right, I think that was a good review from last week. So today, you guys are going to explore metals by describing the characteristics. You might already know some characteristics. What do you know about metals? What are they good at, or how do they look? They are hard. They're shiny. We have a special name for shininess. It's called luster. So they're lustrous. They have a high density. They do react quickly with oxygen to form rust. Excellent. Cool. So their high density goes along with, well, no, it doesn't go along with that they're hard. Those are different things. Copper rust, yeah, it turns green though. It doesn't turn red. You think of iron rust as all rust, but copper turns green when it reacts with oxygen. Aluminum turns white when it reacts with oxygen. So yeah, anytime you've got that like coating on a metal, that's their form of rust. It's called oxidation is the term when you react with oxygen. Cool. So you guys already have some properties down. You'll get some more when you go through. Cameron, yes, they are moldable. And there's a special name for that as well. It's called malleable. And I'm going to use save there. I'm putting these in the notes. I think I spelled malleable correctly. It may just have one L. And also, that goes along with that is that they are ductile, which means you can make them into a wire. Like, here's a wire. Ta-da! A paperclip is a wire. If iron wasn't malleable, we wouldn't be able to make a paper. If it wasn't ductile, wouldn't be able to make a paperclip. All right, so we'll do locations, which are pretty straightforward, and the reactivity. And back. Let's see, we get out of here at 11:30. We did pretty good today. Yep. I think we did pretty good. So you'll find out where the alkaline earth, and transition metals are located, and reactivity. Cool. Oh, one more reminder from Einstein. I kind of already did this. How many valence electrons do group 13 elements have? Yeah, you guys got this. And good morning, Amanda. All right, so you guys are going to go through the metals lesson in Canvas. And you're going to put your questions on the whiteboard. Well, I put it in the notes area. You just put your questions someplace. Have you all figured out where you like to list questions? I kind of like the note area. We'll try it. No worries, Amanda. All right, so if you guys have some good ideas about where to put questions, please let me know, and then we'll come back and recap. It's going to take a little more than 5 minutes because we are now going to change up the recap a little bit and actually get some interaction like we did for the introduction. Okay, so we're done at 11:30, so we'll go with maybe 15 minutes to work. So if you are ready to work, I can put you in that breakout room, and I'm going to pause my recording for those who weren't here. I'm recording. All right, so we've had some time to work in Canvas. So now I would like to recap. Please, if you have any questions that you've run across, please put those in the chat. I'm going to minimize the whiteboard, or you can put them on the note board. And hello, Quentin. Yeah, you're going to have to finish later, kind of finish up on your own time. You should definitely go through it. And then I think that the most important part here is the check for understanding. So that can find what you know and what you don't know. But definitely you want to be going through each lesson in its entirety. Okay, so let's list. We'll put it on the whiteboard here. Let me refresh my layout. And you guys should have tools. All the properties of the metals on the board there. Okay, you should be able to draw now, or write. All the properties of metals. Are you guys writing in white on the board? Or is it not working? What's going on? Maybe I'm not able to see it. Hey, there I see something. You know, it's weird how big this board is, that maybe you wrote it somewhere that I can't see it. Make it full screen. At the top, Rukaya, I wonder if you're writing on your personal whiteboard. Like I have my personal one and the group one, and in the center at the top of the whiteboard, you can switch from your personal one. Okay, I don't know why I can't see your malleable. I'm disappointed because I'd really like to see it. So I've got lustrous and shiny. Yeah, Seth, you can do that, that they react with oxygen to form rust. That's good. Hi, melting point. All right. Good. Oh, I see good conductive on the bottom. Y'all know that there's a feature where you can type on there too, right? The text box. Ooh, I see opaque, ductile. Excellent, excellent, excellent. We're just gonna have to practice with the whiteboard, I think, more. It's so hard to see everything. All right, well, let me give you my list. So I've got malleable, we got ductile, we got good conductors, you got lustrous, opaque, high melting point. I stuck that last one on there. That was the only one y'all didn't miss. Give yourselves a round of applause. Excellent, you got all of those except I added that last little one on there. They form positive ions. And positive, I call them, help remember, because cat ions are positive. So think about a cat being a positive thing. Hope you remember that cat ions are positives. It only works if you like cats, though. And I woke her up. She's not very happy. I woke her up. All right. What is the name? Resize this a little bit of each of these groups. And y'all can pick up the mic or just type in the chat. So let's do the first one. I'll give you some choices. Maybe you all didn't get to that in the lesson. That is my guess since I'm getting crickets. So let me just show you these. Oh, now you guys. Alkali metal is the first one. Yep, and it's got one name, alkali, because it's in group 1. The alkaline earth metals, it has 2 names, alkaline earth, and it's in group 2. And then there are a lot of transition metals. So the lanthanides and the actinides down here. Oh, the key means it's the key. It's the answer to the question. Those are really there for me so I can tell which slides have the questions and the answers pretty easily. But I like to use those little visual triggers because I'm super visual. Okay, it looks like Amanda, you like those too. All right, and our last thing, ooh, did anyone figure out which is the most reactive element? Metal on the periodic table, which is the most reactive metal? You want to take a guess? Look at that, Rukaya found it. Seth, that's an interesting way to think about it. Making, those are called alloys when you mix all the different kinds of metals together. That could be crazy. But francium is the most reactive. Notice it's down here in the corner. The corners, the F's in the corners are the most reactive ones. And based on the fact that francium is the most reactive, when you go down a group, does reactivity increase or decrease as you go down a group? Down. So, and think that francium is the most reactive. Anyone want to agree or disagree with Amanda? Exactly, it's going to increase as you go down. What if we go, this should say from left to right. What if we go from left to right this way? What happens to the reactivity? Ignore my typo. So I hear decrease. Anyone not want to agree or disagree with Amanda? We're agreeing that is good because as you go from left to right, it's decreasing reactivity. And I will end now with my contact information, my phone number and my email address. You'll see that at the end every day, and a nice little quote here from Nelson Mandela. And that is it. I thank you all for coming in. I look forward to seeing you tomorrow. And we're right on time. Bye, guys. Have a great day.